All right, this is going on page 66, and we're done. Okay. We have 4 different rules that we're going to look at. First one is triangle proportionality theorem. I can't really fold my board like you have your paper folded. So inside this, when you open this little door up, you see this. Okay. So the triangle proportionality theorem, starting up here, says if a line parallel to a side of a triangle intersects the other 2 sides. So here's the line that is parallel to this side that intersects 2 sides. All right, so let's just pause right there. Line segment EF. Have we had something that kind of looked something like this before that we've already talked about rules of? What was it? Well, in a triangle, though. The mid-segment, okay? So the mid-segment. EF could possibly be the mid-segment. If it is the mid-segment, then it is parallel to BC and half its length. That's not what this is. Doesn't say that. So it's not specifically the mid-segment. If it was, then point E would have to be related to line segment AB. How? It would have to be the what? The midpoint. It would have to be the midpoint. If E is the midpoint of AB, then this would be a mid-segment. Okay. So again, this applies to the mid-segment. It could be the mid-segment, but we don't know if E is the midpoint. All we know is that it's parallel. So regardless of where it goes through the triangle, if it goes through both sides and it's parallel to the 3rd side, knowing that not every segment that goes through a triangle is a mid-segment, and not every line that goes through a triangle is necessarily parallel. Like I'd have to either know that it's parallel or be able to figure that out somehow. But if that's true, then it divides the sides proportionally. It divides the sides proportionally. Which means that, again, if E was the midpoint, then these 2 would be congruent and these 2 would be congruent. That's not necessarily true here. But because it divides it proportionally, the line has actually set up the proportions for us. This piece over this piece equals this piece over this piece. You see how they're already all set up for you? Just kind of extend it. Those are your fraction bars. So the length of AE over the length of BE is equal to the length of AF over the length of FC. So if you know they're parallel, then they are divided proportionally. I have not said that anything is congruent. I have not said that anything is bisected or anything necessarily. It's just that they are proportional. Okay, we good? All right. Any questions at this point? So that's the triangle proportionality theorem. You got the parallel line going through there. You got some proportions. Then the next one is the converse of the triangle proportionality theorem, meaning that it works in the opposite direction. So here, this says if you know the line's parallel, then the sides are divided proportionally. This one says if the sides are divided proportionally, then the lines are parallel, right? So kind of the same thing, but it depends on which one comes first. So this says if a line divides 2 sides of a triangle proportionally, then it is parallel to the 3rd side. So here, I have this triangle with this line going through it. If I wasn't told this proportion right here, if I just pretended like that wasn't there and all I had was the picture, that's not enough. Maybe that's parallel, maybe it's not. We don't know. But either they have to tell me that it's proportional or I'd have to have the numbers to be able to set it up to see if they work. But when I set this up, if this piece over this piece, AE over EB, equals AF over FC, if this is true, then these have to be parallel. Okay? That's not an assumption. Okay? My conclusion would be that line EF is parallel to line segment BC. So no, they didn't tell me that, but I was able to conclude it based on this converse. Everybody okay with all that? Any questions? No. Wait, what? Where did I lose you? Because that's what's in the picture. I could have said line segment EF and line segment BC, but we're talking about a line that and then a side of a triangle, so I just used it. But whether this is we talked about the line segment, either way, doesn't matter. We good? Anything else? Okay. So then the next one is the 2 transversal proportionality. So this says if 3 or more parallel lines intersect 2 transversals, then they divide the transversals blank. All right, so first of all, here's 3 lines, here's 2 transversals. Are these 3 lines parallel? We don't know is the best answer, right? Maybe they are, maybe they aren't. They kind of look like it, but the only way this works is if they're parallel. Now, if just because they look that way, you don't get to willy-nilly go be adding things to it, right? But I'm telling you, we're going to add it because it actually is a property. The picture just didn't have it for some reason. You only get to add it and use it if I tell you you can, because sometimes y'all get excited and you want to go label things and make them things that they're not, and then they get you all confused. Okay. So yes, now we have 3 parallel lines cut by 2 transversals. When that happens, then they divide the transversals proportionally, which means, again, that my little fractions are set up by these lines. They're my fraction bars. This piece over this piece equals this piece over this piece. So the length of AC over the length of CE equals the length of BD over the length of DF. Everybody okay with all that? Any questions? All right. And then the last thing we have is the triangle angle bisector theorem. So in this triangle here, how many triangles are actually in this picture? 3, okay? But what we're looking at is this as one triangle with a bisector in it, which does create 2 other triangles. But we're talking about the big one, and then this being an angle bisector. I know that this is an angle bisector because these 2 pieces here are congruent. So this angle bisector here comes and intersects the opposite side. These 2 pieces are not necessarily congruent. They can be, but that would only happen if it was an isosceles triangle. But it does divide them into 2 pieces. And then these 2 pieces are proportional to the 2 sides of the triangle. So an angle bisector of a triangle divides the opposite side into 2 segments whose lengths are proportional to the lengths of the other 2 sides. So what this says is, if you make the first fraction out of the 2 pieces and the second fraction out of the 2 sides, so it comes over here, then this piece over this piece, so the length of BD over the length of DC. Now it really wouldn't matter which one I put on top as long as I stay consistent now. So since I put this piece over this piece, when I go to make the fraction of the sides, I have to start with the side that actually touches that piece. So basically I'm going left, right, left, right. And so this would be AB over AC. Okay, so they're divided proportionally. It is possible that, again, that things could end up being congruent by coincidence, and every now and then things like that will happen, but in general, that's not what any of this is saying. Okay? Any questions about any of those? All right, so let's go do some examples. So if you open it up the other way, you've got room to do examples. And we can use both of these sections here to actually do our work and write things in. Okay, so for this first one, I want to find the length of DG. So I'm going to put X on DG so that I have something to call it. Of the 4 things that we just talked about, which one do we get to apply here to actually solve for X? The first one. This is the triangle proportionality theorem, right? Because this is parallel, which means that these are divided proportionally, so there's my little fraction there, right? So I'm going to use the triangle proportionality theorem to do this. So I can set up my proportion. 32 over 24 equals 40 over X. Okay. Now, this is a proportion. I can cross multiply. That makes it very simple. I can also reduce before I cross multiply, but listen very carefully. I can reduce this way. I don't get to reduce this way. Okay, so I can reduce the fraction itself. Can I reduce this fraction? Yes. What are these both divisible by? Okay, 2. So we can do it a piece at a time. Well, let's start by doing it a piece at a time. So I'm going to come over here and do 32 over 24. If I do them both by 2, that's going to give me 16 over 12. Can I reduce again? Yes. I can make that 8 over 6, and then that reduces to 4 over 3. Okay? So I heard some other numbers. And again, if you see something different, you can use something different, but there's nothing wrong with just kind of doing it in stages. So what I've done is I've taken this and reduced it down to this so I can replace it with that fraction because it has the same value. You with me on that? So that's going to give me 4/3 equals 40 over x. Okay? So then I can cross multiply. So when I cross multiply, I'm going to get 4x equals 3 times 40. So 4x equals 120. And what does x equal? 30. Okay. And so then I get, am I done? No. So the length of DG is equal to 30. And now I'm done. Everybody okay with that? Any questions? All right. Okay, so now the next one says, are the segments parallel? So I have all the pieces on there, but I'm trying to figure out if the lines are parallel or not. So what am I going to apply here? The converse, okay? So I'm going to apply the converse, I'm going to write that over here. Converse of the triangle proportionality theorem. Okay, and we are going to use up all of this space because we're going to do this. I'm going to show you how to handle some things when you get big numbers and so that you don't just have crazy work all over the place. So what I want to know is if I have a true proportion. Well, I want to know if these are parallel. So again, I have these already set up. These are where my fractions come from. This is going to give me 67.5 over 54. And then I want to know, is that equal to 90 over 72? Everybody with me? All right, so in order for this to be a true proportion, I can check this out a couple of different ways. I can cross multiply and see if I get the same value. Okay, and if I cross multiply, I'm not solving for anything, but if I cross multiply and I get the same number twice, then it's a true proportion, right? And if it's a true proportion, then they're parallel. You with me on that? Do you really want to go multiply 67.5 times 72? Yeah, me either. Okay, I mean, we could, and it's possible that's one way to do it. But another way to see if they match is to reduce the fractions, which also doesn't look like it would be very, very fun, but it's not going to be as bad as you might think. So let's start with the 90 over 72. So I'm just going to rewrite 90 over 72. Okay, and then I'm going to reduce that. They're both divisible by 9. Everybody okay with that? So we can do 10 over 8, and then what does that reduce to? 5 over 4. Okay? Everybody okay with that? So this 5/4 right here can be replaced with that one. So now I have 67.5 over 54 equals 5 over 4. But that's still a question mark because I'm not sure. That's what I'm trying to figure out. Now at this point, if I cross multiplied, at least the numbers wouldn't be as big, right? It's not quite as bad. So again, could stop here and do that. But I can also reduce this fraction because I want you to know how you can handle this if you actually needed to reduce it. So you can multiply any fraction by what value or by what number and not change its value. 1, right? So that 1 can be 1, which is very uneventful. The 1 could be 6 over 6. It could be 12 over 12. All those still equal 1, right? So what can I multiply 67.5 by to make the decimal go away? 2 or 10. I heard them both. And either one of them is fine. We're going to go with 2, but there's nothing wrong with 10. You just have to end up reducing more in the end. But if 10 was the first thing that you thought, that would work. But what I can't do is just multiply the numerator, right? Because then that changes the value. But if I bring this over here, and now I'm going to take 67.5 over 54, and I'm going to multiply it by 2 over 2, right? Because that has a value of 1. So when I go to multiply the 67.5, what's 2 times 60? 120. What's 2 times 7.5? 15. So 120 and 15 is 135. And then 54 times 2 is 108. Okay. All right, so now I've got that, which still probably doesn't scream at you like, hey, divide me by whatever. But it's better than the decimal, right? We know 2 isn't going to work, 5 isn't going to work. Does 3 work? Yes, 3 works. Okay, so 3 goes into 135. Well, it goes into 13 4 times, right? With 1 left over, then 3 goes into 15 5 times. 3 goes into 10 3 times with 1 left over. 3 goes into 18 6 times. Can I reduce that some more? Yes, they're both divisible by 9, right? So that's going to give me 5 over 4. Is that good news? Yes, because this right here I can now replace with that. So now I have 5 over 4 equals 5 over 4. So they match. So what does that tell me? That they're parallel. So the answer is yes. And your explanation is all of your work that somebody has to be able to follow. Okay? You can't just say yes and put 5 fourths equals 5 fourths without anything to back up how the heck you got that. You with me on that? Are there other ways to do it? Yes. If you feel like another way is better, that's fine, but you've still got to be able to. If the numbers were a lot smaller, I probably would have just gone ahead and cross multiplied. Of course, if they were a lot smaller, it would have been easier to reduce the fractions too. But there's just different ways to manipulate the numbers. Okay, but make sure you know how to handle a decimal and a fraction where you can still work with it and still no long division anywhere. Okay, we all good? So now, this next one. If I'm trying to find the length of each segment, what am I going to apply here? Good. It's the triangle angle bisector theorem, which says that you got the 2 pieces, so you can set up a fraction of the 2 pieces. We'll put 6 over y minus 1. That has to equal, what would the next fraction have to look like? Good. 9 over 2y minus 4. Everybody okay with that? Piece over piece equals side over side. Left over right, left over right. So then we cross multiply, and now I'm going to get 6 times 2y minus 4 equals 9 times y minus 1. So did I write all that down correctly? No, I didn't. Parentheses, because the parentheses are important. If you have more than one term, you have to put it in parentheses, even if they're not there. That's what I'm multiplying. First step, 0 work, you write it down. Then you distribute, and this is going to give me 12y, what? Minus 24 equals 9y minus 9. So then that's going to give me 3y equals 15. So y equals 5. All right, so I'm supposed to be finding the length of each segment, so I've got to do 5 minus 1. So the length of CD equals what? 4. And then I've got to do 2 times 5 minus 4. So the length of AD equals 6. Remember, you got to show the plugging in of it even when it is super easy. Any questions? Okay. So then the next one. What am I applying here? Okay, 2 transversal proportionality. Is that it? And the triangle angle bisector theorem. I got to do them both. Because it asks me for the length of each segment. And there's some of this you can't even read. This weird looking thing, I don't know, some of it got cut off. This is a 9. And then this thing that's kind of like a 1, this is really 10 right there. Well, I know it doesn't look like it. I don't know what happened. But all right, so what I'm looking for, I'm finding the length of each segment. So that means I need the length of QR, I'll call that X. And I need the length of TS, I'll call that Y. So can I start with the triangle angle bisector theorem and find TS first? No, because I don't have X, right? I got to have X first. Do I have enough information to find an actual number for X? Yes. And this X is the 2 transversal proportionality. So here are my 3 parallel lines. Here are my 2 transversals. And so the proportions are already set up for me. I've got 4 over 6 equals X over 10. Okay, so yes, we could cross multiply, but you can also just look at this as an equation, right? X is being divided by 10. What's the opposite of division? Multiplication. So I can just multiply both sides by 10, and get, these cancel out, so I get x equals 4 over 6 times 10 over 1. And then I can reduce before I multiply, so these are both divisible by 2. And then when I multiply straight across, I get that x equals 20 over 3. Well, when I started, I said we could just cross multiply, but we can also look at it as an equation. So you take away from that what you think. So what am I actually looking for here? Do I just box x and move on? No, it says find the length of each segment. So I need to answer that, and that is QR is equal to 20 over 3. And so this gives me 20 over 3. Okay. QR is 20 over 3. But now I also need to find TS, right? And by the way, Rigo, if by multiply 4 times 10 and do it that way, if you actually write down 6x equals 4 times 10, yes. But if you just do it, you're not going to get credit for any of it because you didn't show your work. First step, 0 work, write it down. Okay. So now I've got piece over piece equals side over side. So I've got 20 over 3 over what? Over 10 equals the side which is 9 over the side which is y. Piece over piece equals side over side. Everybody with me? Understand where everything came from? We have a fraction and a fraction. Do we need to like freak out? No, because it doesn't even matter. So when I cross multiply, I get 20/3 times y equals 9 times 10. So 20 over 3 times y equals 90. I need to get y by itself, so what do I do? Okay, so why do I multiply by the reciprocal? Well, yeah, but why is that what I do? Because what you're really doing, well, that's the problem, is that your teacher never actually told you why. And the only reason you're doing it is because your teacher told you to. Do you know why? Can you tell me? Tell me. Tell me why we multiply by the reciprocal here. Huh? Well, yeah, I know, to get y by itself, but why is that what we do? Because if I have 5x equals 10, you don't I'm not talking to you. Do we multiply by something here? Right? So why am I multiplying by something there? So why does it multiply? Okay, so instead of making smart aleck comments when I ask questions, why don't you pay attention? Because maybe if you weren't talking and trying to be funny while Nathan was talking, you would have heard his answer and he was right. So would you like to say it again? Because you were right. Tell me what you said. Why do we multiply by the reciprocal? Because the opposite of multiplication is division. Okay? It's the same steps. You are dividing by 20 over 3. And when you divide by a fraction, the rule for dividing by a fraction is to multiply by the reciprocal. Okay? That's a fraction rule that some of y'all didn't even realize you knew. Right? It's a fraction rule. So I multiply both sides by 3 over 20. Oh, but not 30 over 20. Huh? Multiply by 3. I am dividing by, this is being multiplied by y. So I'm going to divide by 20 over 3. When you divide by 20 over 3, you multiply by the reciprocal. That's what that whole conversation was. Okay? Put that over 1. So these cancel out. So then I can reduce before I multiply. I can knock out those zeros there. And so then y equals 27 over 2. Oh, and then I don't really want to box that one, but it's fine as long as I still answer the question, which is the length of TS is really the answer. 7 over 2. It's okay that y is boxed as long as you actually box the right answer also. Okay? Any questions about that? Basically, they both divided by 10. You can reduce before you multiply. Fraction rules. Okay? Anything else? Alrighty. Okay, so go ahead and glue that in.